Hello, and welcome to the Space Above Us. Episode 97, Space Shuttle Flight 27, STS-27. All tensed up. Last time, we talked about STS-26. Space Shuttle Discovery returned the human space program to flight after a lengthy hiatus. The flight successfully proved that the upgrades to the shuttle system worked, deployed the TDRS-C satellite, and added 5 Hawaiian shirts to the list of objects flown in space. The flight completed all of its objectives, but did have a concerning incident with damage to the thermal protection system. In what is starting to become a sadly familiar story, debris had once again shed off of the shuttle stack and impacted the fragile orbiter thermal protection system. It would not be the last time. STS-26 and its crew were able to bask in the limelight of being the first shuttle crew to fly in almost 3 years, while restoring NASA's crown jewel to operational status. STS-27 would be a little different, since for the third time we have a completely classified shuttle mission. No basking allowed. These classified missions were a major headache for all involved. One crew member's wife said that trying to plan for family and friends to attend the launch was like trying to plan a wedding, but you can't tell anyone the date. During their training, crew members weren't allowed to talk about where they were going, what they were doing, or when they'd be back. When the launch day did come, it came with little warning to the general public. Even on the day of the launch, with countdown operations clearly underway, details like the exact time that the crew entered the spacecraft were kept secret, and the T-0 time wasn't revealed until shortly before liftoff. This level of secrecy, even on launch day, might seem silly. After all, what could be more obvious than a space shuttle launch? But as we learned on STS-1, it's possible for space-based assets to move into position to observe a launch if you have precise timing. By keeping the time of liftoff as hazy as possible, NASA, or rather the Department of Defense, hoped to keep prying orbital eyes far away. As always with the classified mission, we don't know a ton about the payload, but we do know some things. But let's talk about that once we get on orbit, and instead meet the crew. Given the classified nature of the mission, it shouldn't be a surprise that we're once again flying with an all-military background crew, 3 from the Air Force and 2 from the Navy. Commanding the mission was our good buddy Hoot Gibson. We know Hoot as pilot from STS-41B and commander of STS-61C. You might be wondering why Hoot is flying again so soon, as I'm sure a lot of his unflown classmates were. The simple answer is that the DoD wanted someone who had already flown as commander to command this flight, to help ensure the success of the mission. Hoot actually protested the choice to George Abbey, saying that it just wasn't his turn. But, well, the DoD gets what the DoD wants. So, his turn or not, this is Hoot Gibson's 3rd out of 5 flights. Joining Hoot up front was pilot Guy Gardner. Guy Gardner was born on January 6, 1948, in Alta Vista, Virginia. He earned bachelor's degrees in astronautics, mathematics, and engineering sciences from the Air Force Academy and a master's in astronautics from Purdue. He flew 177 combat missions in Southeast Asia at the controls of an F-4 fighter jet before becoming an F-4 instructor and eventually making his way to test pilot school. He became an instructor there as well before shipping off to the Philippines as a test squadron operations officer, which is where NASA found him in 1980. This is his first of 2 flights. At the back of the flight deck, we find mission specialists 1 and 2, Mike Mullane and Jerry Ross. We know Mullane from his flight on STS-41D, the first flight of Discovery, and we know Ross from STS-61B, where he got to assemble the Tinker Toy-like ease and access experiments in the payload bay. This was Mullane and Ross's 2nd of 3 and 7 flights, respectively. Riding down on the middeck was Mission Specialist 3, Bill Shepard. William Shepard was born on July 26, 1949 in Oak Ridge, Tennessee. He earned a bachelor's in aerospace engineering from the U.S. Naval Academy, and later at MIT an ocean engineer degree, whatever that is, and a master's in mechanical engineering. Shepard was a Navy SEAL, specializing in underwater demolition, which is probably one of the few jobs to rival astronaut in terms of training and challenge. He was selected as an astronaut in 1984, making him the first of his class to fly. And Shepard will be with us for a while, with his 4th and final flight being the commander of the first crew of the International Space Station in the year 2000. One interesting note, this crew is mostly who was going to fly the STS-62A mission, the first shuttle flight out of Vandenberg on the west coast. Bob Crippen moved up to management, so was replaced by Hoot Gibson. Dale Gardner, no relation to Guy, retired from NASA and was replaced by Bill Shepard, and the 2 payload specialists were cut. Pretty close, though. Which makes sense, since this was actually the same payload, which also explains the relatively high inclination orbit. After losing support from the DoD and out of concerns with the lighter SRB design required for polar orbit flights, all Vandenberg payloads were either adapted to lower inclination orbits or to other launch vehicles. One quick side note for those of you who wish I covered more of the Russian side of things. I did want to mention that about 2.5 weeks before STS-27 started, the Soviet Union launched their own orbital space plane, the Buran. This STS orbiter lookalike had some pretty impressive technical features, and successfully completed its first 2 orbits after lifting off on November 15, 1988, completely uncrewed. Unfortunately, it was also the last flight. And since Russia is Russia, the spacecraft was eventually destroyed when the hangar it was stored in collapsed. It's an interesting and sort of sad story, but it's a story for someone else to tell. We've got our own shuttle to launch. The first launch attempt of the 3rd flight of Atlantis was scrubbed by upper-level winds, but a day later, on December 2nd, 1988, everything was ready to go. Even the newly updated cork insulation on the SRB field joints. After the concern on STS-26 that shedding pieces of cork could have caused the gouge in Discovery's heat shield, new precautions were taken. The cork was inspected with ultrasonic instruments, and wherever voids were found, they were filled with epoxy using a hypodermic needle. Yet another source of shedding debris to keep track of. On launch day, there were 2 minor delays due to high upper-level winds at the Kennedy Space Center and unacceptable weather at a transatlantic abort site. But after those minor delays, Atlantis lifted off once again at 9:30 a.m. Eastern Time, blasting up the east coast of the United States into a 57-degree inclination orbit. The crew and mission controllers noted no anomalies during ascent, and shortly after main engine cutoff, they got to work. The primary task on STS-27 was to deploy the classified spacecraft taking up most of Atlantis' payload bay. Officially, all we know is that the spacecraft cost about $1 billion in 2019 money, which is a lot even for a satellite, and that it was deployed by the Remote Manipulator System with Mike Mullane at the controls. That's it. Even all these years later. I'm honestly not sure why 31-year-old shuttle payloads still need to be classified, but I guess that's why I'm not in charge of classifying stuff. Thankfully, we know a little more than the official story, thanks to reporters at places like Aviation Week and Space Technology, and little bits of the story that have leaked out over time. What we think we know is that the spacecraft in question was the first Lacrosse satellite, which used synthetic aperture radar to peer through darkness and clouds in order to surveil other countries. Suddenly the high inclination orbit makes sense. With a 57-degree inclination, it would fly over a good chunk of the Soviet Union. But I bet if they had flown out of California as intended, it would have had complete coverage. Oh well. We're already a little familiar with synthetic aperture radar thanks to instruments on STS-2 and STS-41G, which carried SIR A and B respectively. Or maybe it's SIR, I'm not sure. In any case, with clever use of radar, this spy reconnaissance satellite would be able to keep an eye on what's happening on the ground even through foul weather, which I imagine comes in handy in Russia. In fact, this radar technology can even look a little bit underground, discovering stuff like ancient riverbeds. But something tells me that's not what this spacecraft is for. One thing that's kind of cool about Lacrosse was that it was so expensive that they took special measures to make sure that it could be brought home even if it didn't work. With all of its long appendages deployed, Lacrosse was about 150 feet wide, which is far too big to fit back into the payload bay. So after deployment, Atlantis would hang around for a little bit to see how things were going. If there was a problem, the crew could command Lacrosse to jettison its appendages, allowing for recapture and return home of the expensive core. Neat. In fact, it seems there may actually have been some sort of a problem. I hesitated to bring this up because I really have no good source at all, so please just take this for what it is, but when digging around on this flight, both in print and online, I've heard rumblings of a significant issue. The rumblings are backed up by a stray mention of a rendezvous here and an accurate EVA count there, stuff like that. For example, as I understand it, NASA was all set to celebrate the 100th EVA on a much later mission, but then sort of just dropped it without bringing it up again. The story goes that someone realized that there were classified EVAs that had accidentally been counted, or that they weren't being counted, so the 100th EVA celebration was wrong. Whether or not STS-27 included a secret spacewalk, we simply don't know, because the crew certainly aren't saying. So please take that previous paragraph with a boulder of salt, but it's fun to think about. In any case, Lacrosse was seemingly happy and healthy at the end of the mission, so whether it was deployed that way or got a little help from the STS-27 crew, it was able to do its job. With the primary objective complete, the crew were free to enjoy the rest of their short flight on mid-deck experiments, Earth observation, the usual. And with the usual comes the usual slew of minor problems. There was a printer jam, forcing the crew to use a backup method of receiving schedule updates and the like. And one morning they discovered about 2 gallons of water just floating loose around the floor of the middeck, thanks to the failure of some environmental control equipment. Oh, and due to a slow tire leak that had been noticed before the launch, Gibson and Gardner had to keep Atlantis' belly facing the sun. This would keep the tire warmer and ensure that they had enough pressure to safely land. But the fact that they launched with this issue tells you how minor it really was. Not every problem on this flight was minor, however. In fact, though nobody realized it at the time, Atlantis would soon become known as the orbiter with the most damage that still came home safely. It started when, after analyzing video of the launch, Mission Control asked the crew if they had seen any debris go by the window. That's not really a question you want to hear. There was concern that debris had shed off of the shuttle stack, impacting the underside of the orbiter. Mike Mullane got the robot arm ready again, but this time, instead of deploying a billion-dollar top-secret satellite, he was going to carefully, oh so carefully, extend the arm over the side of the orbiter in order to take a peek at the thermal protection system. What the crew saw shocked them. Among the sea of black tiles were a constellation of white flecks. The underside of Atlantis' right-hand wing was covered in hundreds of chips and gouges. The all-important thermal protection system, the delicate silica tiles that kept the orbiter's aluminum frame safe, was severely compromised. The crew immediately reported their findings to Mission Control, who soon wanted to see it for themselves. And here we hit our first big problem. The DoD didn't want any video being downlinked from Atlantis during this classified mission. This seems silly to me since the payload had long since been deployed and was happily doing its thing many miles away. But maybe accidentally seeing the support equipment in the payload bay would give something up. Or the payload itself might be visible as a distant dot that could be triangulated using stars and other imagery techniques. Who knows? The point was that the secrecy-minded folks were not a fan of sending down real-time imagery. But they arrived at a compromise. Encrypted video. But here we hit our second big problem. Encrypted video is great if you want to keep something secret, but it resulted in a far lower resolution image, something the crew was unaware of. So they had no idea that the folks on the ground analyzing this video for heat shield damage were looking at a super low quality image, which explains their shock when the ground proclaimed the damage to be nothing to worry about. And that's where our third big problem comes in. Due to the low quality video, the ground thought there wasn't actually any significant tile damage at all. They thought they were just seeing lights and shadows on the belly of the orbiter. But instead of telling the crew, "We don't think you're seeing tile damage," they just said it wasn't a problem. It was a fundamental miscommunication. Had the crew known what the ground was really thinking, they maybe could have found another way to communicate the issue. But instead, all they could reasonably do was shrug, say that they were the experts, and continue on with the mission. In that moment, however, Commander Hoot Gibson became convinced that the flight would end in catastrophe. We'll get to the end of the flight in a bit, but first we can have a little fun. As Hoot put it during the flight, no reason to die all tensed up. Aboard Atlantis was a football that was to be presented to the NFL commissioner at the Super Bowl. Typically, when some ceremonial thing like this is flown, it's tucked away in some inaccessible place, presumably to leave more of the accessible locker space available for the crew to use. but the football was added late, so it was just sitting in one of those mid-deck lockers. The crew knew this, so they went and found it. The football was deflated to save space, but astronauts are a tenacious bunch, so they figured out how to partially inflate the football using a needle intended for food rehydration. The ball wasn't inflated properly like a real football, but it would look the part for some videos. Since the crew couldn't film their actual work thanks to the DoD, they staged a series of short clips of some zero-G antics. In one, Mike Mullane catches the ball and attempts to run downfield, float mid-deck, only to be confronted by 3 floating linebackers who tackled him, sending all 4 spinning out of control. In another, all 5 men huddle up as if discussing strategy for their next play, and suddenly Hoot Gibson's head pops up and squints at the opposing team, the one that wasn't there, before waving at the audience. They also tried to go all Skylab on us and run around the floor, ceiling, and walls of the middeck. There's a great clip of Guy Gardner starting off pretty well before tumbling out of control once he got to the ceiling. The PR folks might get annoyed when the news chooses clips like this instead of serious work, but nothing beats a good zero-G Olympics. Like most of these hop-and-pop satellite deployments, before they knew it, it was time for Atlantis to return home. With the severe damage to the orbiter's thermal protection system, the crew knew that they might be in for a rough ride, one that they might not walk away from. But there was nothing they could do but put their trust in Mission Control and in the army of men and women who built their spacecraft and worked to keep them safe. Well, there was almost nothing they could do. Commander Gibson knew that if the right-hand wing started to disintegrate, there would be some telltale signs ahead of time. For example, at the back of each wing there was an elevon, a large movable control surface. Hoot knew that if the orbiter was coming apart, the right and left elevons would start moving to different angles in an attempt to compensate for the asymmetrical drag. He decided ahead of entry interface that if he saw such a discrepancy, he would radio down to Houston to let them know what he thought of their tile damage analysis. Incidentally, that would actually be possible thanks to the newly commissioned TDRS-3, which was delivered by Discovery on STS-26 and was now parked over the Pacific Ocean. Atlantis would be able to communicate with TDRS-3 during reentry since it was behind the orbiter, so there was no need to punch through the plasma sheath. As I understand it, they would sort of look back up the plasma pipe that they were tearing through the atmosphere. With a much shorter blackout period, Hoot would be free to deliver his assessment of the TPS damage analysis. So I guess that's something. Not all of reentry was this grim, however. For one thing, spoiler alert, they landed safely. But also, Mike Mullane did a very strange thing that makes for a fun story for us. For entry, Mullane and Bill Shepard had switched seats, so Mullane would be down on the nearly windowless middeck. Not wanting to miss out on the reentry light show, he got Hoot's permission to hang out at the back of the flight deck for the initial entry. Since the plasma show gets started well before the aerodynamic forces really start kicking in, he should be able to enjoy the view, float back down to the middeck, and strap in before gravity really took hold again. Well, the first part of the plan worked, but Mullane seems to have forgotten how captivating the view from a re-entering shuttle could really be, and how rough gravity feels after a few days of weightlessness, especially with 70 pounds of new gear. Realizing that he had waited too long, he eventually sank down to the floor and had to crawl over to the ladder and ploddingly make his way down and into his seat to strap in. First Mike Lounge barely makes it back to his seat and gets strapped in before launch, if he even did, and now this. What's with people named Mike getting out of their seats on the space shuttle? Just stay in your seats, people. Despite concerns about the thermal protection system, after 4 days, 9 hours, 5 minutes, and 37 seconds, Atlantis successfully touched down for the 3rd time at Edwards Air Force Base. So it seemed that maybe this crew's concern and plans for critical last words were for nothing, right? Well, not quite. When the crew emerged from their spacecraft, there was already a crowd of technicians gathered around the right side of the vehicle. What they were staring at was the worst damage ever seen on an orbiter. Spread along Atlantis' belly were over 700 impacts to the delicate thermal protection system, with almost 300 that were at least 1 square inch in diameter. Worst of all, on the right side of the forward fuselage, just behind the forward RCS module, was an entire missing tile. Underneath where the several inch thick tile should have been was a bubbly burned mess. The orbiter's skin had started to burn through. Just by chance, under this tile was a small door that provided access to an antenna. The tin plating on the outside of the door had melted completely, and the aluminum under that was starting to buckle. Through pure chance, this door, which was slightly thicker than the rest of the orbiter's skin, took the brunt of the damage. If another tile had been missing, who knows what would have happened. Oh, and just to throw in one sort of bizarre coincidence, among the VIPs at the landing was our old friend Alan McDonald and his family, who were attending as guests of Hoot Gibson. I say it's bizarre because the cause of this near catastrophe was the SRB. Though it was specifically a part made by different contractors, so we can give Morton Thiokol a pass for now. I know you're all dying to know what happened here, so let's just get into it. For some of you this will mean nothing, but others will appreciate that I literally read a 77-page TPS report for this section. Well, a thermal protection system report. Specifically the STS-27R OV-104 Orbiter TPS Damage Review Team Summary Report, Volume 1. The report is actually pretty fascinating, and it's available on NTRS if you want to take a look for yourself. Just 3 days after Atlantis landed, a damage review team had their first meeting. They looked at this incident in just about every way imaginable. They reviewed imagery, they reviewed telemetry, they interviewed the crew, they sampled the damage, they inspected photos of the external tank after jettison, and they examined the returned SRBs. They painstakingly counted every piece of orbiter heat shield damage and assembled their findings into a database. And then they did that for 19 previous flights so they can make direct comparison. Their comparisons to previous flights had some obvious findings and some not so obvious findings. One of the obvious findings was that this was quantifiably the most damaged orbiter to come home, by a lot. A sort of interesting, less obvious finding was that they started looking for correlations between various parameters, and they found that having more ice on the pad actually correlated with less TPS damage. That probably doesn't mean that the ice is somehow protecting the TPS, but I think it pretty safely rules it out as a culprit in this incident. By analyzing trace material left in the craters and gouges in Atlantis' thermal tiles, the team were eventually able to narrow the list of potential impactors down. And since only one of those was even physically possible, it seemed that they had found their suspect. The ablative material that protected the SRB nose caps. Each nose cap was coated in a material called Marshall Spray Ablator 1, or MSA-1. Usually you think of ablative heat shields being used on the way back from space, not heading up to it. But the shuttle stack blasted through the atmosphere so quickly on the ride uphill that the nose caps needed a little help. But hang on, a few trace materials are one thing, but was this even physically possible? Was there a path that MSA-1 material could take from the right-hand SRB nose cap to the damage area? Yup, analysis showed that there was. Alright, but how strong was this material? Analysis had shown that in order to cause enough damage to a tile that it would break away during entry, we'd need a piece of MSA-1 that was around 10 inches long, 5 inches across, and a 1/4 inch thick. Launch imagery indicated that the impact took place around 85 seconds after liftoff, well into the region of supersonic flight. Was MSA-1 even strong enough to survive tumbling through supersonic airflow while traversing the shockwave coming off of the orbiter's nose? Actually, yeah. Simulations showed a 70% chance of such a piece surviving long enough to impact the orbiter. Okay, so the trace materials found in the damage indicate that it could have been caused by the MSA-1 on the SRB nose caps, and analysis showed that it could have survived the trip from the nose cap to the side of the orbiter. But that just raises the question of why now? Was this nose cap different? Actually, yeah. MSA-1 is degraded by humidity, so since it had to survive the Florida climate, after being sprayed onto the nose cap, the MSA-1 would later be covered with a special paint to protect it. In fact, that paint was one of the trace materials found in the orbiter damage sites. Typically, the paint was applied about 15 days after the MSA-1, but that process wasn't tightly controlled, yet. So for whatever reason, for STS-27, the paint was applied 45 days later, which would have led to significantly more degradation of the ablative material. So there you have it. Degraded ablative material applied to the right-hand SRB nose cap shed off about 85 seconds into flight, striking the orbiter, cracking a tile, and causing hundreds of smaller impacts along the right side of Atlantis' wing. The tile came off during entry and nearly burned through the skin. The crew of STS-27, along with the overall shuttle program, had dodged a bullet. The damage team included a number of recommendations in their report. Some basic stuff like reevaluating the design of components for possible debris shedding was a no-brainer. They also recommended a comprehensive database of damage to the thermal protection system. The fact that they had to make their own is sort of telling about how this issue was being handled. They also included recommendations like using onboard cameras, more launch imagery, and favoring remove and replace instead of in-place repair when it came to TPS tiles. Some recommendations were followed, some weren't, and some lessons had to be learned again later. The easy part was swapping out the material on the nose cap. The upgraded MSA-2 flew on the very next mission. One last note about this TPS damage. In the course of making this episode, I took a look to see if former flight director Wayne Hale had any thoughts about STS-27 on his excellent blog. Among the comments, I found a response where he indicated that while debris shedding was battled for the entire program, it was always looked at as a maintenance issue and not a flight safety issue. That is, the concern wasn't that debris might result in the loss of the orbiter and its crew, but rather that it would lead to more time-intensive and costly maintenance. I think it's easy in hindsight to look back at incidents like this and ask how the potential for disaster wasn't obvious. And often it's not obvious in the moment with the information they had available. But for this one, I really can't do anything more than shake my head. Next time, we get to try out that upgraded nose cap material on STS-29. Yes, 29, missions are getting shuffled around again. Just be glad we're not calling it STS-91B. Ad Astra, catch you on the next pass.